Kia ora and welcome to the first screencast for the first workshop for 161122 statistics. So you can see here I'm on stream, so I thought I'd start with just showing you how I would load a workshop session up. So let's click on the first week here, and so we can see the first workshop, and I'm just going to click on that and it will open in a new tab. And I get a quick guide for how to do things. So I'm just going to read through this briefly. So our goal is to produce some plots and learn a bit about how R and RStudio works. So before we start, we make sure we have downloaded both R and RStudio and installed them onto our computers. And in addition, that we've made sure we have the tidyverse package installed. And so you can click on this link here to find out how to do that. Okay, so you can read that guide there, which is quite detailed. Okay. So now we're going to load up our first R script. So we're going to start by downloading the first lab workshop file onto our computer. So you can see here the easiest way to do this is to right click on the URL. So we just put our mouse on it, right click. If you're on a Mac, that'll be a double tap. Okay, and we're just going to save link as or save file as, depends on the browser. So I'm going to save it, and I am going to put it into a folder that I'll remember. I'm just going to put it in here. Save. So I'll put it into data teaching 161122 screencasts. Okay. And then I'm going to load it into RStudio. So the fail-safe way to do that is to first load RStudio up. So I'm going to run RStudio. And then I'm going to go to File, Open File, and browse to where the file was saved and loaded up. Okay. So here's RStudio. So I'm going to go to File, Open File, and I'm going to browse to where I saved it. So it was in Data, Teaching, 161122, Screencasts, Lab 1. And so you'll get this loaded up on the right here, top left here. Okay, and what we're going to do is just work through the script. Okay, let's bring back our document. So we're going to start by reading through things, and then we're just going to figure out what things are doing and so on, and see how we get on. So let me just pull this perhaps out into a separate pane. Okay, so that we can work through this. Okay. So this is our RStudio editor, and this is where we're going to be doing our typing and saving the things that we type. Down the bottom here, we have the RStudio console. That's where code will be executed and output will be spat out. Okay, and we also have the environment up here, which is where your data sets will show up and things like that. And you can see at the moment my data set is empty, and then you have a bunch of tabs down here, and at the moment we've got some files down here. Right, so you can see that at the start we've got a bunch of comments. Okay, so comments are prefaced with a hash character. Okay, and you can see are showing up in italics and orange. Okay, so lines that start with a hash are just comments. You can write anything we like there, and they'll be ignored when we run them in RStudio. So they're useful for adding notes that will remind us what the heck we're doing when we come back to the workshop next week to try and figure out what we did this week, because we'll forget. Okay, lines that don't start with a hash are then interpreted potentially as code. So you can see that the first line that we have as code is this library command. You can see that it's sort of formatted, the library's a different color and so on. It'll be the same on yours, it just might use different colors. Okay, I've just got a different theme loaded for RStudio. So library tidyverse, and when we run that, so to run that, what I'm going to do is just put my cursor anywhere on the line and click the run button, and you can see that when I hold my mouse over that, it says that run the current line or selection, and we've got a shortcut Control plus Enter. So on a Mac that'll be Command Enter. So I can either click the run button. Okay, you can see that when I did so, it copied the comment that was preceding it and the command, and then ran it down in the console here. And you can see that spat some stuff out. Okay. Now none of this is anything to worry about. Even this, these little red X's and so on. It's just telling us. It's providing a message telling us all the different packages that it's loaded. So the tidyverse package is what's called a meta package. So a package for R is just like an add-on, if you like. So the tidyverse is an add-on, but it's an add-on that loads a bunch of other add-ons. So you can see here that we've loaded the ggplot2 add-on package, the Tibble, tidyr, readr, per, dplyr, stringr, and forcats. We'll see what all these other ones are later on. And it's also telling us that there's some conflicts. So the dplyr filter command is masking the stats filter command and so on. That just means that there's, because there's so many different add-on packages for R, those add-on packages often have functions that are named the same as functions in other packages. Okay, and which package you load last is the one that generally takes precedence. So if we're using the filter or lag commands, before we load library tidyverse, they will be the stats filter and stats lag command, whatever they do. But after loading the tidyverse, when we use filter and lag, they will be the dplyr versions. We'll learn about this a little bit later on. So the next command we're going to run is the data command, which is loading the Quakes data. So you can see that when I run this, it copies the line of code down to the bottom, down to the console here, but there's no output from that. But you can see here that I've got a promise in the environment. And this is essentially just a thing such that when it sees Quakes, it knows to go and find that data and spit it out for us. And so when we start using that data, that promise will turn into what it actually is, so what the data actually combines. Okay. Right. Okay. So we might be able to yes. So if I click on the Quakes there in the environment, you can see that now it's loaded. So I've got 1,000 observations of 5 variables. And if I double click on it, then it will load it up into a little spreadsheet style view. And you can see that I have lat, long, depth, mag, which is presumably short for magnitude, and stations. So this is the latitude and longitude that the earthquake, where the earthquake was. This is the depth, I think in kilometers. And this is the magnitude of the earthquake. And this is the number of stations at which the earthquake was detected. So there were a number of earthquake detecting stations around, and this is telling you how many stations detected that earthquake. And of course it's based on where the stations are and which ones detected it that you can figure out where the latitude, longitude, and figure out what the depth and magnitude and so on are. Okay, so now we're going to do a plot. Okay, so this is a plot that's in the same form that we've used before, the same recipe. So we've got ggplot to start telling R that we want to plot. We've specified the data set that we're going to use, so we want the Quakes data set. We've then specified a layer, so a geometry that we want to use. So in this case, we're going to be using points, and because we're using points, we then need to specify how we get the x and y coordinates of those points, and so we have a mapping that maps from our Quakes data to the x and the y. So you can see here that x is going to be our longitude and y is going to be our latitude. So if I just put my cursor anywhere on those two lines and control enter to run, or press the run button, you can see that it will copy those two lines down to the console area and execute the code, and I get my plot popping up here. Okay, so these are the earthquakes around the Fiji region. I think Fiji's in around here somewhere, and New Zealand's down here. Okay, so it's a very large region around Fiji. And you can see that there's sort of areas where there are more earthquakes than in other places. Okay, so now we're going to break down what this code is actually doing. Okay, so we're going to do that just by running the lines in segments. So we're going to start by just seeing what the ggplot does by itself. So say we only had this piece of code. What does that do? Then when I press Control Enter or click the Run button, you can see that I get a blank plot. Okay, so it's created a plot. It's actually done something that we can't see, which is that it's associated the data, the quakes data, with that plot. Okay, but that's all it's done. Okay, so it's created a new plot and associated the quakes data with it. So the next step is to add other stuff on. Okay, now a common fault or a common mistake that you might make is that when I copied that, you'll notice that I didn't copy the plus. If I had copied the plus, what would have happened? Let's have a look. So let's put the plus on there. If I try and run this now, you can see that it doesn't actually do this bit up here. So you can see that I've only got the one blank plot there. I haven't got a new one. You can see that it's given me a X, unexpected end of document. And you can see down here in the console, it's copied that code across, but I'm just left with a little plus here. And that little plus there is just telling me that it's expecting more input, right? Because we've given it a plus, and so it's looking for what we want to add on to that ggplot function. So it's sort of a common thing to happen when we're doing charts, because we need to use plus to sort of add the different bits together. That sometimes you end up with a plus on the end of the last line, and you execute the code, and it sort of does this. And now I'm sort of stuck a little bit. Like if I try and run that line there, you can see that it added that on. So we've got the code that is actually executed is ggplot plus data equals quakes plus data quakes, and it's all messed up. We've got an error, right? To get out of that, so if you ever see a little plus down here rather than a little the sort of the greater than sign, which is the normal prompt, if you ever see that, the way to get out of it is just to hit the escape key. So if I hit so you click down into the console and you just hit the escape key, and it'll give me back my prompt. Okay, and now I can execute other code. So for example, I can execute this. Okay, so just something to watch for. Okay, what about this bit in the middle here? What's this bit here doing? So let's have a look at that AES bit. Okay, so let's write some notes. Creates a new plot. Okay, you can see that that's defined the aesthetic mapping. So it's defining how X and Y on the plot should be derived from our quakes. In this case, we're asking, we're saying that X should be taken from the long variable, a long column, and Y taken from the lat column. Okay. Right. Okay. What else? Okay, so lastly the geom_point bit. So if I combine them all together, adds a geometry layer to our plot. Okay. So there we go. Right. Now we'll try adding to our plot. So for example, we can try changing the color, shape and size. So let's try running that. So you'll see here that when I wrote this code, I've specified the color as pink. I've used quotes around the pink. Because that's a label, right? We don't have an object called pink up here that we can use, and so that's why there's quotes around it. There's no need for quotes to be around 2 because that's a number, right? So the size is 2, as in 2 units. Obviously I could change that, right? I can make it 3 and I'd get bigger points, okay, or 0.5 and I'd get smaller points. Okay, so you can sort of change things as you wish. Notice the other thing is that when I specified the color and the size, I didn't put them inside the mapping. So you can see that the first argument to geom_point is the mapping. The mapping bit, the AES bit, takes stuff only from our data. It doesn't take, so if we're wanting to set features of the plot to a specific value, to a constant value for all points, then I specify it inside geom_point, so it's an argument inside geom_point that is specified via commas, so separated with commas, but they're not put inside the mapping argument. Okay, just a note that when I do this, when setting aesthetics, make sure you put them outside the mapping equals AES bit, but inside the geom bit, e.g. this is wrong, spelt wrong even. So if I tried putting that color equals pink inside here, what would I get? I would get red points, which are not pink. Okay, so what that's done is it's essentially added a column to the to my quakes data with pink specified for every observation. Okay, and it's then treated pink as a grouping variable and treated that column as a grouping variable, and so it's just said color is equal to pink for all observations, which is not useful. Okay, so whenever we put we're setting aesthetics, we put it outside the argument. The same thing would happen if I tried to put size inside. Okay, right, what else? So let's experiment with some other things. So we can also change the shape. So let's perhaps change the color to something else. Does it know what maroon is? Or maybe change the shape to squares. See if that works. Yep, so now we've got some maroon squares. We can also change the transparency with alpha. Okay, so we can say alpha is 0.5. We'll make everything 50% transparent. Okay, so 1 is completely opaque and 0 is completely transparent. 0.5 is 50% transparent. Okay, so we've got some see-through things here, and the nice thing about this is it sort of allows you to see the density of points quite nicely. So you can see here that there's a lot of points in this region here and in these regions up here, which were a little bit harder to see before when we didn't have the transparency because all the points were on top of each other. So while we could get the impression, we couldn't really get the full idea of just how dense things were. Now if we want to actually find out the rest of these things, we could look at the help for geom_point. So to look at help, there's a couple of ways to do it. One way is to just click the help button and just type in the thing that you want to find help with. So in this case we want to find help with geom_point, and then it will find the help for geom_points. The other way to do it is to use a question mark and then geom_point and run that. That will bring up the same thing. Or you can just put your cursor, so finding help, or you can just put your cursor on the geom point, the thing that you want to find help about, and press F1. Okay, and that gives you the same information. And if we read through this, we can see that we've got this geom point, so this is the usage, these are the parameters. So our first parameter is mapping. Interestingly, we can also specify data here. That's useful if you want to specify, if you want each layer in your plot to use a different underlying data source, which is sometimes useful for more complicated plots. And then as we go down, you can see that mapping, a set of aesthetic mappings created with AES. And as we go down, you can see some information about overplotting. The biggest potential problem with a scatter plot is overplotting. Whenever you have more than a few points, points may be plotted on top of each other. This can severely distort the visual appearance of the plot, and there's various solutions to the problem there. And then aesthetics, geom point understands the following aesthetics. The required ones are in bold, so it requires X and Y, but it has all of these other ones that it can have. So alpha is for transparency, colour is the colour of the point. Some points have an outside colour and an inside colour, whereby the outside colour is colour and the inside colour is fill. Group, we'll see that a little bit later, what that means, but basically that's a grouping variable, so you can sort of force the points to be associated with one group or another. That's particularly useful when you start using lines. So we'll see that later when we use lines. Shape, size, and stroke. So stroke is the outside nature of the point, so you can change things like the for the shapes that have an outline, you can change how big the outline is. And we can see that we can learn more about setting these aesthetics in the vignette ggplot spec. So if I just copy that code and put it here, then when I run that, I get aesthetic specifications. And so now I can read all about the different ways of specifying my aesthetics. So for colour and fill, we can use a name. So we've been using that already. So we've used the names pink and maroon, red. It has 657 built-in named colours, which can be listed with colours. Okay, so here are all the colours available. Okay, Peach Puff 3, excellent. Papaya Whip, so there you go. Lots and lots of colours. You can see it's got 100 shades of grey, or 101 I guess, because there's grey 0. And also with it spelt with an A. So while it's got 657 colours, 200 of them are grey. But you know, it's got lots and lots of different interesting colours that you can explore if you wish. You can also specify them with an RGB specification with a string in this form here. So you use a hash, then then RRGGBB, where the pairs RRGG and BB are hexadecimal digits. So one way to find this is you can use a color thing in a browser. All right, so if I just go to and just say colors, color picker, color wheel, there's a color picker here, right? And so I can just choose a color. So if I want maybe a green, sort of something like this, I can just sort of choose the color that I want. And once I'm happy with my color, maybe I want a sort of a khaki type color, perhaps that, I can grab the hex there, copy that, and then I could put it in here. Right, so let's use that color. Just copy that across. So okay, so that's how you get additional colors. Okay, right, I think that's all we need to know about aesthetics. Oh, the other thing is, what about the shapes? Let's go back to our help. How do we deal with shapes? So there's various line types for line charts. size, line ends, you can change lots and lots of stuff. Polygons, point shapes, here we go. So here are the different shapes, so you can specify them by a number if you want to memorize numbers. So the normal default shape is shape 1. Here we go here. Let's copy and paste this code. So now, if I look at shapes and run that, here they all are. So here's all my shape names. Okay, so we've got circle, so that's the default shape, but there's lots of others, right? So I could use diamond open, for example. And there I get an open diamond. Okay, the ones that are filled, like triangle filled, diamond filled, and so on, they're the ones that have separate fill colors. So I'll show you an example of that. So if we go we could go diamond filled. So when I do that, you'll see that that by default the fill color is empty. But now I can color the inside of the points and the outside of the points different. So this is particularly useful when you use a very light color. So for example, if you use yellow for the fill, then you could use a darker color for the outside so that you can pick it up. Because without the outside, you know, if the outside was also yellow, then it's a little bit hard to see the points on a white background, for example. So that can be used there. And then I think you can specify the stroke to change the width of the black line on the outside, so you can make it real solid or real narrow. Okay, so that's how you can mess about with that. Right, and the last thing I think we're going to look at is mapping the color. Okay, so let's add color equals mag. Right, so you remember with our quakes we've got the latitude and longitude, but we've also got the depth, the magnitude, and the number of stations at which it was detected. So you can see that when I map it to magnitude, because magnitude is a continuous variable, it's given me a color scale. Okay, so you can see here that the big ones are only, you know, are sort of scattered about. These are sort of quite a few big ones down in here. And we might want to also potentially color by station as well. Station is not found. I made a mistake there. Let's have a look. Oh, it's called stations. So common mistakes are to type things wrong, make a typo. Whenever you see object something not found, it's usually because you've made a typo. So have a look in the data and make sure that you've typed the right case. So if I used a capital S, I would also be wrong, right? Because the column starts with a lowercase s. Station. So there's the stations map. Let's get rid of this one. So that was a mistake. Made a few mistakes along the way. There we go. So there's the magnitude, and there's the number of stations, and you can see that those maps look very similar, right? The colors that are the highest in both plots are basically the same, and that's of course sort of makes sense, right? A larger earthquake, so more magnitude, is going to be detected at more stations, so we would expect a correlation between those two. And maybe the last thing we'll do is try colouring, changing colours. Viridis is quite a nice palette to use. Right, so if you go scale, colour, viridis, and just choose one. There we go. So this is a binned colour. So you can see here that the colours have been, it's not a continuous scale, it's been binned into 6, that's what the B is. Continuous scale I think is C. Here's a continuous scale. Okay, and there's lots of other ones that you can play around with. I can't remember what the difference between C and D are. D's a discrete scale, which doesn't make any sense because we've got a continuous variable. There we go. Okay, so feel free to change, to play around with different colour schemes. Okay, I'm going to save that now. It's already saved. You'll notice that when it's not saved, it's got a little star by it. And I periodically, just because I'm used to it, I'm Control S to save, but otherwise you can just go File, Save. Now, a common thing that people ask is, can I save all of this stuff? Or what do I do when I make errors? You'll see that I've just ignored them. So this, the output in the console here is basically, it's like a stream of consciousness. And it's ephemeral in that it's going to disappear when I go out of RStudio and come back. So what I try and do is when I'm writing my code, I'm putting it all up in here. I'm putting it all in this R script because that R script is saved and it's got everything I need. So if I come back in, if I clear everything out and come back in, I can reproduce everything I've done just by running all the code here. Right? So for example, let's just quit out of RStudio. Okay, and then I'm going to go back into it. Okay, and I'm going to reload that file. So where did I put it? In here somewhere. There it is there. And so you see that none of my plots are there. All my plots are gone, all my output is gone. But that doesn't matter because I made a habit of writing all my code here. So if I just select all this and hit run, it'll go through and run all the commands that I did today, and I've got all my plots that I can run through. Every single one of them. Okay, I've also got all my output, including any errors that I would have made. Okay, it will be all here as well. I don't think did I make any errors in this code? I don't think I did I? No. So make sure that this here has no errors in it so that when you come back to it and rerun it, you don't have any issues. But don't worry so much about stuff that you leave in here. Okay, that's it.